With worsening climate change around the globe, climate action is one of UNESCO's Sustainable Development Goals. My homeland, Philippines, is a tropical country that is constantly experiencing harsh weather patterns and increasingly rising sea levels. No wonder, our geography makes us a ground zero for natural disasters. In fact, we are the third most vulnerable country to climate hazards according to 2016 World Risk Index. To aggravate the issue, climate change makes the matter even worse. That is why, even if the Philippines is only a minor emitter of greenhouse gases, with only 0.3% of global emissions, climate change is a vital issue for us, making the Philippines one of the signatories of the Paris Agreement on Climate Change Pact. The country is predominantly agriculturally based, whose staple food is water-reliant rice. Thus, any disaster caused by climate extremeness would mean a double-edged sword: starvation to the communities and economic loss, especially for the fishermen and farmers. The two climate extremes which the Philippines periodically experiences are the so-called El Niño, or extreme dryness, and La Niña, or extreme wetness. These oceans besetting children, El Niño, or the little boy in Spanish, and La Niña, or the little girl, are the so-called opposite phases of ENSO, which means El Niño Southern Oscillation. In a nutshell, ENSO is a scientific term which is defined by Wikipedia as an irregularly periodic variation in winds and sea surface temperatures over the tropical Eastern Pacific Ocean, affecting much of the tropics and subtropics. While the word La Niña is not found in the acronym ENSO, or El Niño Southern Oscillation, ENSO is actually a catch-all word referring to a single climate phenomenon with three states. First is the El Niño state, which is the abnormally warm phase. Second is the La Niña, or the abnormally cold phase. And third, the neutral state, which is in the middle of the continuum. What exactly is El Niño? What is La Niña? And when do they occur? On El Niño, here is an excerpt from the 2015 privileged speech of Philippine Senator Lauren Legarda. She is also the designated Global Champion for Resilience by United Nations International Strategy for Disaster Reduction.
We ask, what is this weather system? How was it formed? El Niño is a cyclic warming of surface ocean waters in the East Pacific. And during El Niño, the usually strong easterly wind becomes weak. It becomes incapable of pushing warm water in the West Pacific region. Therefore, rains are diverted eastwards, causing enhanced rainfall in the Eastern Pacific and less rains in the western area. This phenomenon is identified when the temperature reaches 0.5 degrees Celsius or higher for at least 5 consecutive months, overlapping 3-month seasons. And this we have experienced in the Philippines and many areas in the world. It is part of a climate system occurring every 4 to 5 years. And imagine, Mr. President, this is just 0.5% degrees Celsius. What about the projected 1.5 to 2 degrees Celsius rise in temperature?
So, El Niño is the warm phase of ENSO, and it can last from at least 9 months to 2 years. El Niño is usually formed in the summer between June and August and gets strongest in December and then fades away in between May and July of the next year. In contrast, La Niña, the cold phase of ENSO, refers to the cooling of the ocean surface or below average sea surface temperatures in the central and eastern tropical Pacific Ocean according to National Weather Service. Unlike in El Niño, the cool waters from the deep ocean are directed towards the surface as upswelling strengthens. In general, La Niña occurs after El Niño and lasts typically between 9 to 12 months or shorter than El Niño. In terms of frequency, La Niña is also less frequent than El Niño. How does the variation in pattern of El Niño and La Niña actually compare to the normal condition? Well, we can see La Niña has the following characteristics. The sea surface temperature is below average. The warm pool moves westward. The cold tongue that is located in the eastern Pacific Ocean has strengthened. The slope of the thermocline steepens. The wind pushes warm water westward, and the anomalies show a cooler water that unusually extends farther westward. In the Philippines, more clouds are formed, thereby generating more rain. In contrast, El Niño has the following features when compared to a normal condition. The sea surface temperature is above average. The warm water has spread from western Pacific Ocean towards the east in the direction of South America. The cold has weakened. The slope of the thermocline flattens. The wind pushes warm water eastward, and the anomalies show a warmer water going eastward. This illustration from the book Dire Predictions: Understanding Climate Change characterizes the El Niño and La Niña events. So, to summarize, what are the inputs or causes of El Niño and La Niña? There are 4 basic indicators: the sea surface temperature, the surface pressure, trade winds, and clouds. In an El Niño episode, the winds going from the east to west are not as strong as normal. Consequently, much of the warmer water are simply left in the eastern part of the ocean, which causes a self-perpetuating cycle of making the winds even weaker due to the warmer water. It only stops when it grows large enough to reach the middle of the ocean, creating the so-called Rossby waves. It takes months for these Rossby waves to get to the shore and then bounces back from the shore to the ocean, which is called the Kelvin wave. Such return Kelvin wave brings enough cool water with it, which effectively cancels the warming from the El Niño episode. That is why La Niña often follows El Niño, but it is not always the case. La Niña can occur independently. For example, if the winds described earlier are rather blowing stronger instead of weaker, and with colder water, then the result would be La Niña instead of El Niño. What are the outputs or impact of El Niño and La Niña? For the Philippines, which is in the Western Pacific region, El Niño can result to droughts, bushfires, heat waves, and consequently, depletion of farms and croplands. According to the Philippines Department of Agriculture, the damage caused by El Niño in 2016 include $325 million worth of total damage and production losses in crops. 16 out of the country's 18 regions, particularly those in Mindanao, were affected by El Niño. On the other hand, La Niña can cause super flooding, more tropical cyclones, early rain season, short dry season, above normal rainfall, and strong monsoon activity. In 2013, the Philippines experienced an extremely powerful Typhoon Haiyan, which is also known as Super Typhoon Yolanda locally. It is the deadliest on record so far, killing at least 6,300 people in that country alone and affecting at least 11.5 million Filipinos. Both El Niño and La Niña can result to loss of life and property, health problems like malaria, dengue or waterborne diseases like cholera, extensive damage to crops, damage to infrastructure, economic losses due to traffic, work and class suspensions, and disruption of learning and education. Now, let us consider the time frame to gain insights on the patterns and trends. Since the cycle of El Niño and La Niña is predictable, occurring typically 2 to 7 years, knowing when it will occur is crucial to everyone at stake so they can adequately prepare to mitigate this. In the Philippines, the official weather bureau is called PAG-ASA, which stands for Philippine Atmospheric, Geophysical, Astronomical Services Administration. That acronym is in fact a local term for hope. PAG-ASA is a member of the World Meteorological Organization. The past. Since 1950s, strong El Niños happened in the year 1957, 1965, 1972, 1982, and in 1997, which is a very powerful one with warm water penetrating eastward. El Niño years can be seen through the so-called anomalies, which indicate how much the sea surface temperature is different from the usual value for each month. In the Philippines, the strongest El Niño so far was in 1997 to 1998. It affected 2.6 million Filipinos and caused at least 3 billion pesos loss in agricultural crops like rice and corn. At present, it was in 2015 when the long dry episode occurred, prolonging until the first quarter of 2006. In North Cotabato, Philippines, the extreme dryness was so severe that the region has been declared as in the state of calamity. On the other hand, globally, there was a strong La Niña in 1988, which scientists believe to be responsible for the summer drought over Central North America. Another La Niña in the middle of 1998 continued to persist in the winter of 2000, resulting to very active hurricanes in 1998 and 1999. In the Philippines, one of the most tragic effects of La Niña was in 1999, when the landslide at the Cherry Hills subdivision in Barangay San Luis, Antipolo City took the lives of at least 58 people. Moving to the present time, the State Weather Agency PAG-ASA said last February 2017 that the La Niña conditions are no longer present in the central and eastern equatorial Pacific. So, when is the next El Niño and La Niña in the Philippines, counting from end of November 2017? With regards to El Niño, the Secretary of the Department of Agriculture in the Philippines has warned the public that we and other poor countries have to be prepared in 2018 because another long dry spell threatens to happen by the end of 2017 or early 2018. This is based on the projection of the Australian Weather Bureau that the Pacific Ocean could warm up again. On the other hand, in terms of La Niña, based on the latest climate forecast of NOAA in November 2017, there is 65 to 75% chance that the La Niña conditions will continue through the Northern Hemisphere between October and November and may last through first quarter of 2018. But the La Niña event will be relatively weak and will not last beyond March 2018. 2 to 5 tropical cyclones may affect the country between November 2017 to April 2018. How can my country address these twin climate extremes given the limited resources? Since El Niño and La Niña are predictable, then these are preventable crises, but adequate preparation is the key. The holistic approach to address El Niño and La Niña will chiefly be a fourfold strategies. The preparedness strategies to be done before the El Niño or La Niña event, the mitigating strategy or activities during the calamity to minimize damages, the resilience strategy or initiatives to help the victims recover, rehabilitate, and reintegrate quickly, and the educational strategy, which are aggressive educational and informational campaign to raise awareness, get active involvement, and empower the victims and the community to address the problem together. The recommendations come from best practices around the world as deemed applicable in the case of the Philippines, such as the Oxfam's Preventable Crisis Study, UNOCHA, UN Development Program, and California's Drought Drone Technology. First, preparedness strategy. These are proactive initiatives and forecasting methodologies before the event to address the potential ill effects of El Niño and La Niña. These include better forecasting tools, hazard mapping and early warning systems, risk-sharing mechanism like crop insurance, comprehensive research and development, having a memorandum of agreement among all stakeholders, early procurement of life-saving relief items. Additionally, for El Niño, this includes having a drought drown system like in California, reduction of water loss through the canal lining and irrigation canals maintenance, alternative farming measures, and for La Niña, this includes establishing of windbreaks, improving pumping capacity, and protecting water sources from contaminated water. Second, mitigating strategy. These are activities during the calamity which will protect lives and minimize the adverse impact of extreme climate. These include multi- and cross-sectional coordination of all concerned by activating the Memorandum of Understanding and Agreement, timely response to hotspot areas, water recycling, providing the basic needs including evacuation centers. For El Niño, it also includes livelihood intervention, reactivation of deep well sources, cloud seeding if necessary, and deployment of portable water treatment facilities. For La Niña, it includes provision of water pumps, provision of drainage to remove stagnant water, and promoting good water hygiene. Third, resilience strategy. This refers to increasing the capability of the susceptible victims, such as farmers and fishermen, to recover quickly after tough disasters by providing multidimensional support before, during, and after the crisis. This includes the creation of El Niño La Niña Task Force, which will provide the leadership and support throughout the crisis, support to livelihood cooperatives, and well-planned investment in infrastructures. For El Niño, it is also recommended to maintain a higher level of minimum water supply for consumption during drought years. For La Niña, building storm surge barriers in low-key areas are very important. Finally, educational strategy. This refers to specific educational program to promote awareness and climate action of a certain target group of people. Examples are aggressive information dissemination in schools, local and national communities, international community, and social media. Intensified educational training to the affected communities and practical information guide. A separate educational lesson plan was prepared for this course that is targeted to secondary school students in public schools located in the most El Niño La Niña prone areas. Our very own Philippine Senator Lauren Regarda has also shared some practical tips during her privileged speech in 2015. She said, "We cannot stop this El Niño. The most that we can do is prepare for its adverse effects in the water and food sectors through water conservation. Let us practice measures to efficiently use our water resource like gathering and storing rainwater for daily chores, using water dipper instead of shower when bathing, turning off faucets properly, and immediately repairing leaking pipes and running toilets, among others. We can surpass this dry season if we consolidate all efforts and do our share." In conclusion, we see that El Niño and La Niña are natural phenomena which cannot be stopped. But thankfully, these are still a preventable crisis because these can be forecasted by weather authorities. Thus, our collaborative proactive attention should be focused on prevention or preparedness as the primary mitigating strategy. Quality education, which includes intensive information campaign, coupled with climate action, are strong forces for the Philippines to be prepared and resilient in overcoming the ill effects of El Niño and La Niña. Climate change has supercharged El Niño and La Niña and can bring more climate extremes. We need to do our part now, individually and collectively, with a sense of urgency as a small way of doing justice to our generation and the future.